Okay, so numbers 19 through 25. Very much like we just did before, simplifying each expression. You got a lot going on here. Sometimes you're going to be needing to use your properties of exponents. Sometimes you want to keep it as a radical. Sometimes you want to write it in exponential form. Got to remember a few things. If you remember in the lesson, it's not considered simplified if you have a square root in the denominator, okay? Also, no parentheses are allowed to exist, no negative exponents, no powers of 0. So also you want to make it to where you only see each base appear once. So sometimes you have to make the decision. Do I need to leave it in radical form or do I want to leave it in exponential form? So for number 19, if you look, I have different roots, but I have the same base. So for number 19, it's probably going to be easier to write it in exponential form. So x to the 4 over 6 over x to the 2 over 4. Now, the rule says if you have the same base, you want to subtract your exponents. So, and this is the quotient rule. So what I want to do is I want to subtract my exponents. So x to the 4 6 minus 2 fourths. Okay, well, I need to find a common denominator. So looks like 12 is going to be my common denominator. So I'm going to multiply this one by 2 over 2. And I'm going to multiply this one by 3 over 3. So 4 times 2 is 8. 2 times 3 is 6 over 12. 8 take away 6 is 2. So this becomes x to the 2 over 12. Well, we want to reduce that fraction. 2 over 12 simplifies to 1 over 6. So there's one of your answers, x to the 1/6. Or the other way you can write it is the 6th root of x. Okay, so the next one, number 20. So 20, we have, it looks like we've got two bases, a base of 2 and the base of y. So I want to put an exponent there, so y to the first power. So rule is, same base, add the exponents. So this becomes 2, y 1/2 plus 1. So 1/2 plus 1, 1 1/2. Let's write that as an improper fraction, which is 3 over 2. So this becomes 2y to the 3/2. Again, if you remember what I said yesterday, if it starts as a radical, you want it to end as a radical. Starts as an exponent, end as an exponent. If you want to go further with it, you can, but truth is, this is simple enough. Okay, so number 21. So 27 over 8 to the 2/3. Okay, so again, I can expand that one out, and it's numerical. So probably going to be easier to write this one as a radical. So it becomes the cube root of 27 squared over 8 squared. Okay, so the reason why I did 27 squared and 8 squared is because that whole quotient is in parentheses. So then when in doubt, expand it out. So I'm looking for groups of 3. Well, I know 27 breaks down to 3 times 9, and 9 is 3 and 3. So I've got the cube root of 3 times 3 times 3. But I have 2 sets of those because it's 27 times 27. So I'm going to list that set out again. Okay, so then 8 squared, well, again, 8 breaks down to 2 times 2 times 2. And again, that squared tells me I have 2 sets of those. So what's going to come out of the radical? A 3 and a 3 over a 2 and a 2. Or 9 over 4. So 21, the answer is 9 over 4. Okay, number 22. So for number 22, again, you have to decide radical form or exponential form. What's easiest? Well, for this one, it's easier to leave it in exponential form. Apply your properties of exponents. So if you remember what I said before, all you're doing is multiplying. So since it's multiplication, you want to use the product rule, which says same base, add exponents. But before that, I want to use my commutative property and write what goes together. So I'm going to put my 3 and my 4 beside each other, then x to the 1/2 and x to the 2/3. Okay, so now that I've done that, I'm going to simplify. So 3 times 4 is 12. Then x to the 1/2 plus 2/3. Okay, well, I'm going to need to find a common denominator, which is going to be 6. So times by 3 over 3 times by 2 over 2. So then I'm going to have 12x to the 3 plus 4. So 3 plus 4 is 7. So 12x to the 7 over 6. And that is my final answer. You can also type these fractions into your calculator. I don't have one on me right now, so I'm doing it by hand. So I might have made some mistakes. Just double check my math. Okay, number 23. So in number 23, again, probably going to be easiest to keep it in exponential form. Well, let's start with the 12 over 4. If all I had was 12 over 4, well, that's the same thing as 12 divided by 4. So let's simplify that. 12 divided by 4 is 3. And then, going to use the quotient rule, same base, subtract exponents. So 1/3 minus 1/2. So again, common denominator, which is 6. So times by 2, times by 2, times by 3, times by 3. So it becomes 3y to the, well, 2 minus 3 is -1. -1 over 6. Well, we're not allowed to have negative exponents. So move it to lose it. So 3 over y to the 1/6. Now, technically, this is not considered simplified because you're not allowed to have a radical in the denominator. But for right now, I'm just going to leave it at this. Okay, number 23. So number 23, again, you have to decide which form is better to use, radical or exponential. Well, notice how we don't have the same root. We only do for 2 of those. But we do have the same base. So same base. Let's write it in exponential form. So x to the 1/4, x to the 3/4, and then x to the 1/2. Well, 1/4 and 3/4 adds to 4 over 4. And then x to the 1/2. So, and I skipped a step. At this point, hopefully you should have known where the 4 over 4 come from. I added exponents. So then x to the 4 over 4 simplifies to 1. So I've got x to the first power and then x to the 1/2. I want to add those exponents. So 1 plus a half, 1.5, or x to the 3/2. Now, like I said before, typically, if it starts as a radical, you want to end it as a radical. So the other way you could have written it as the square root of x cubed. And technically, that's not considered simplified because you're looking for groups of 2. So you could have took out your x, one of the x's, and leaving you with an x underneath. So all 3 of those are equivalent to each other. A lot to process. Okay, number 24. Got 2 more to go. So on this one, not allowed to have negative exponents, but also we have parentheses. I would apply my rule where I'm supposed to distribute and multiply where necessary. So 3 times negative 2/3 is negative 6/3. And then 3/2 times negative 2/3 is negative 6/6. Okay, so let's simplify. So negative 6/3 is negative 2. So x to the negative 2 over x to the negative 1. Okay, so now I want to use my rule that says subtract your exponents. So negative 2 minus negative 1, well, when I'm subtracting negatives, that becomes plus a positive. So negative 2 plus positive 1 is x to the negative 1. Not considered simplified because you're not allowed to have negative exponents, so it becomes 1 over x. Final simplified answer. Okay, and then the last one. So again, I want to start off by distributing my exponent. So distribute the negative 1 to everything, including that y. So x to the positive 1/3, y to the negative 1, x to the negative 2/3, and then y to the positive 1/2. Okay, then I'm going to go ahead and subtract my exponents. So 1/3 minus negative 2/3, and then negative 1 minus 1/2. So this becomes 1/3 plus 2/3, which is 3/3. And then negative 1 minus 1/2 becomes negative 1.5. Negative 1.5 is negative 3/2. And so let's simplify. This becomes x to the first power. And we're going to move to lose because it's negative. So x to the first power, or just x, over y to the 3/2. And I'm not going to worry about radical form. I'm going to leave it in exponential. Sorry. Hopefully now you can see that better. Leave it in exponential form. That is my final simplified answer. Okay, so I wanted to take the time to go through and explain all these. You are going to have a quick check to take on SchoolNet to make sure that you're getting this. Guys, I have opened up office hours through Google Invite, through the group chat. So guys, if you need to, make sure that you check in with me. I'm available to talk to and answer questions if you have some. Hope everything's going well. Talk to you soon.